Hello, hi student. Good evening. So today we are going to see the question number 30 for ISRO 2018 set C. Okay, we have completed till now we have completed how many question? 29. Okay, so this is our question number 30. Okay, let us see question number 30. Question number 30 is asking about the communication system. So there is a communication antenna A and B. Communication antenna A and B. One is operating at 300 megahertz and other is operating at 3 gigahertz respectively, and having the same gain and eliminated with identical flux density of minus 100 dB per watt square. Okay. So what is the relation between the received power PA to PA to PB. Okay, so here two receiving antenna is given. Okay, so receiving antenna. So let us say this is my transmitting antenna, and there is transmitting antenna. So this is my transmitting antenna. Okay, and transmitting antenna, and there is a two receiving antenna. Okay, two receiving antenna, one antenna and other antenna. Two antenna is there, or receiving antenna. So these antenna are receiving the power. So this is my power of this antenna, received power of this antenna. This antenna is A and this antenna is B. Let us say this antenna is B. Power received by this antenna A is PA, and power received by this antenna PB is PB. Okay, so these are receiving the power. Okay, so this is through the space. Okay, through the space. This is my EM wave. Okay, through EM wave. So these both receiving antenna, these are receiving the power, okay, from transmitter through air medium. Okay, so now see here, given that the frequency of frequency of this receiving antenna PA is 300 megahertz, and this receiving antenna PB, for this frequency is given as FB is equal to 3 gigahertz. 3 gigahertz. Okay. So now 3 gigahertz. Now asking for what is the ratio? What is the ratio of this PA by PB? Okay. So power flux density is also given. Okay. So as we know very well, what is received power? What is the receiving power of an antenna? Receiving power of an antenna. Receiving power. Receiving power of an antenna. Receiving power of an antenna is given as what is that? Received power is equal to PR is equal to PT GT GR divided by 4 pi R square, divided by 4 pi R. Okay, so this is like PT GT GR divided by 4 pi R square, 4 pi R by lambda whole square. Okay, so this is my received power. This is my receiving power. Okay, so we just want here what? So this is what we just here want. We just want the ratio of this power. Okay, and frequency is given. Frequency is given. So we just need what? PR. PR is proportional to what? Lambda square. If we see from here, PR is proportional to lambda square. Okay, lambda square. Now then we can say that what? PA. So lambda is equal to what? C by F. Yes. So now we can say that received power is inversely proportional to F square. F square. Okay. So from here we can say that PA by PB. PA by PB is equal to what? FB. FB by FA. FA whole square, which is equal to how much is FB? 3 gigahertz, means 3000 megahertz. How much is FA? FA is 30 megahertz. So finally we will get how much? This is whole square. Yes. So let us see how much is this. 3 get cancelled and this is 10. Yes. So 10 to the power. This is 100 to the power square divided by, sorry, this is 300. This is, sorry, 300. Okay. So then this will get cancelled and this is 10 square is equal to what? 100 divided by 1. So we get what? PA is to PB is equal to what? 100 is to 1. 100 is to 1. Okay. So this is option number D. Option D is correct. Option D is correct. Okay. So this is what? This is about question number 30. Okay. One transmitter here, power is transmitting through this antenna through the space. Okay. And power flux density is also given. So that is no need here. Okay. So that we don't need. Okay. Because he is asking just what? Just the ratio. Okay. Just the ratio of what? PA is to PB, and from this relation we can compare and we can directly compare with frequency and we can get the answer very easy. Okay. There is no need to worry about power flux density. Okay. So this is what answer. Just simple. This is what Friis equation. Free what is. Okay. So let us see here. This, if we explain, this is what? PT. PT GT. PT GT is nothing but EIRP. Okay. EIRP. EIRP means this is effective. This is effective isotropic radiated power. What? Effective isotropic radiated power. Radiated power. Effective isotropic. This is what? Effective isotropic. Effective isotropic radiated power. Effective isotropic radiated power. And this term is nothing but 4 pi r by lambda whole square is nothing but, this is path loss. What? Path loss. Path loss, or you can say free space loss. Free space loss. Yes, this is free space loss. Okay. So that's why we can write this received power also as EIRP into GR divided by path loss. Okay. This is extra point you can add, you can know this. Okay. So other than this answer. Okay. So other than this question part, so this you can remember, this is what? Effective isotropic radiated power, which is nothing but PTGT, just. Okay. And this is 4 pi r by lambda whole square is nothing but path loss, or you can say free space loss. Okay. Free space loss, where PT is the transmitting power, GT is the transmitting gain. Okay. So gain of transmitting antenna, and GR is the gain of receiving antenna, and R is the distance. R is what? Distance between transmitter and receiver, and this lambda is the wavelength of electromagnetic signal. Okay. So this is all about